Dennis, do you want to do the honor of introduction or shall I kick it off? I'll do the honor. Everyone, thank you everyone for a very long session on Summit. I've been talking about data and data-driven approach. So we have a fantastic panel that probably span and cover every possible aspect that you want of a organization, from application security to cloud security to vulnerability management to data-driven approach to data science and CISO. So we have the best representative in here to discuss around the table on how to best approach vulnerability management from application security, cloud security, infrastructure, and traditional vulnerability management across the board, and a data-driven approach on this. Before further ado, I want to start and ask all the panelists to do an introduction so that's for the very few people that don't know you guys, and I'm going to go in order, they're going to know who you are and what contribution have you done so far, and you will. Mike, you're the first in the list. Thank you so much for coming. Welcome.
Thank you, Francesco. This is exciting. To be real quick, right now I work at Block on their product security team, and I'm also co-host of the Application Security Weekly podcast, where we talk about all types of things, vulnerabilities, and hopefully more than just vulnerabilities, which I think we'll explore a bit more in this session.
Brilliant. Jay, up to you.
Jay Jacobs. I am the co-founder and data scientist at Scientia Institute, doing a lot of research and publications in the security space. Also the co-creator of EPSS, the exploit prediction scoring system. And I think I'll just leave it there.
Just a tiny bit things that was EPSS in the last year. Thank you, Jay. John.
Right, good to be here. John Kinsella. I am I'm doing a whole bunch of different things right now. I spent this year doing a bunch of independent work for startups, application security, working with some VCs and private equity. More historically, my background is in application security, container security, cloud security. Most recently as VP of engineering at Qualys for their container security product. I'm happy to be here. Oh, also I'm the other co-host for Application Security Weekly.
Brilliant. Thank you very much, John. Chris, after you.
Hey, Frank. It's an honor to be here. I heard they kept the best session until the second last.
Cherry on top.
Rumor has it you may be able to confirm that. Yeah, I work at Yahoo Product Security. My name is Chris Madden, and my overall existence or point of existence is to optimize the flow of software to our pipelines versus security risks. So I have a deep interest in all of the things that we'll be talking about here as a practitioner.
Brilliant. Thank you very much. Marius, over to you.
Hi, guys. Good to be here. So my name is Marius. I'm Global Vice President of Cybersecurity for Go Financial Services.
Brilliant. All right. So we're going to structure the panel, start discussing around different area and aspects of how modern organization works. And I think what I've seen so far is organization works either in silo way, so application security, infrastructure, and cloud security. We want to break this myth and bring across the panel today all these aspects and connect it with risk and executive view and the metrics that matter. So we're going to start on this very easy topic between application security and traditional vulnerability management between Mike and John. What is your opinion on how we've been attacking the problem so far, and how is this problem evolving in this modern age that is a data-driven modern age?
You want to go first?
Sure. Yes, I think we have been attacking the problem, I think, of so many vulns that attackers don't care about. And maybe I'll kick it off like that, because we have so many SAST, DAST, IAST, SCA. We have so many ways to find vulnerabilities. It's wonderful. We've got great observability. But then we turn that around and say, cool, AppSec thinks we should fix all the vulns, or because it's kind of one of those easy metrics to track. And I think one of the things I'd like to especially talk with John about is there's all sorts of vulns that are corrupt, clickjacking, CSRF, RDoS, lots of low impact or no impact XSS. I think some things that I'm kind of hinting at that some other panelists are going to pick up later on. But all of this comes at an opportunity cost as well. There's so many more interesting things that could be done. And I'll tease John a little bit. I love to talk about refactoring and rewriting code, but instead of just refactoring code, we could also actually be working on features or focusing on the features in the software we're building rather than all the dependencies that we're using.
There's the concept of, so I'll try to address this with like the engineering management hat on. And if you think about application security, a lot of our, just think about applications, start there first. Frequently when we think about features, we're thinking about what are we designing and developing for our customers, whether that's an internal customer or a public customer, you know, they're paying in one way or another, or we wouldn't be here. But there's also the features we can be creating from a security point of view. And those could be something simple like how to make sure this application is easier to check if it's secure, or you know, is it being attacked, or things like that. So I think what we've seen, Francesco, is going from that point where we're just purely whack-a-mole, when there was back in the day, there was just enough moles in a room that we could count them and play whack-a-mole. And I think a large portion of what we're going to be talking about here is, as that number has grown to this crazy scale, we ain't got enough hammers, we ain't got enough people. It's not going to work, right? So we can't have a top 10 list for everything. So how do we actually focus on what we want to do here and narrow that down? So I think that's what modern AppSec is about.
Yeah, no, I do agree. I do agree with your point. There seems to be, though, still the affection to top 10 lists. We had the top 10 LLM vulnerability. OWASP top 10 has always been top. We had the top vulnerability exploited, or the top methodology of vulnerability exploited, and when it really matters. What are a little bit from an AppSec perspective, the metrics in the old age? I think Mike touched it a little bit on before, and in the modern age that matters. And I think I want to then after later on ask the same question to Chris, because I know he has a very good opinion on it, so it's going to make a very good discussion point. Mike and John, over to you.
The way I think about this, and I'm not going to look at a pure metric to start. I'm just going to look at the concept of where we're around, which is it starts thinking about asset inventory, which, you know, we're 20, 30 years into security, maybe 50, pick a number, but we still don't know what the hell we're securing in many cases. And where I want to do is pivot that to an application security point of view. What I like, some of the more modern tools, which I like out there that you could call them scanners, are not giving me that list of every asset and every vulnerability on it. It's what can an attacker see and what can they actually compromise or actually have some sort of effect on. That gives me more, where I'm going this is I want a list which is, I want a metric which is something I can execute on, something that's manageable, something that I can make an actual difference, not just in that number going down, but in the product, in the security of my product. So that's the way I think about it in general. I think is what our listeners are going to see here as we talk through this, is there's no one metric which is going to be perfect for everybody, depending on, you know, where your application is, what type of eng team you have, or how your company is set up. There's going to be different metrics that will have a better representation of the state of security of your application. So I think Mike probably going to look at this from a slightly different point of view, but that's sort of, I like to think of it just, I'll leave the actual numbers and things out and let's look at the high level and then start focusing down in, okay, what does that mean for me?
Yeah, and I want to piggyback on that by extending that aspect of what are we trying to communicate and how are we communicating with metrics, et cetera. And probably the only thing that bugs me a little bit more than top 10 lists is metrics that use pie charts. So hopefully there's no pie charts in the rest of this panel. But the reason I picked that up is if we look at, I'm going to just pick on the top 10 API, for example. It has broken authorization in so many, it has 3 or 4 items are just broken authorization, and there's a nuanced taxonomy, but how much of this is actionable? And I think that's what I wanted to hit is the top 10 list giving the developer something actionable, or are we just talking about the taxonomy of this is a type 1 cross-site scripting, this is a type 2, this is the type of cross-site scripting that is blue? Developers don't care about that. They care about, you know, what is the impact to a degree, meaning how should I prioritize this? But should I be using a same site cookie? You know, should I be using, you know, is this actually input validation, or is it really an aspect of access control or an RBAC application or we should be using encryption in a different application layer encryption. And I'm rattling a couple of these off randomly to highlight basically developer activities that don't really get called out in those top 10 lists. They get called out. If a top 10 list says insecure design, that's a little too vague, because if you just invert that and say you should have secure design doesn't mean you don't have any vulns. It means we have to have a longer conversation, probably, than we have time for now.
And how do you measure that upstream and downstream? How do you measure the effect of security design? And how do you inform security design? But we don't want to offend the OWASP Top 10 2021 with security design making the showcase an appearance. But I really like what you said on the actionability. And I think from a security perspective, we get even stuck on the naming convention, because we have CVE, CWE, MITRE and ATT&CK, CAPEC, and the problem is a lot of these are even disconnected from each other. So we have domain of information that sometimes don't translate to engineering. Do I need to upgrade a cookie? Do I need to do input validation? What do I actually need to do with this? But on
Cisco,
that subject,
I think you're working on a top 10 list of metrics there.
please don't.
with pie charts.
So
Top 10 pie charts that are most hated in the community. But on the metric subject, we often debate with Chris on which metrics are actually more measurable. And we've done fairly modern studies, and I really love the approach that Chris has done from a pure data-driven approach. And he's speaking to several conferences about his approach and the data effect that he's seen. But without singing the praise too much, Chris, over to you. Tell us a bit more about...
Frank, please, if you can keep the mic, if you're willing to sing a few bars, then go for it. I won't steal your thunder. But no, thanks, Frank. Yeah, so let's maybe for context, I'll start by describing where we came from, and these points will probably resonate with a lot of folks in development environment. So what we had when we started, we had a mature new vulnerability management capability run by my rock star colleague Lisa for many years, and it basically triages new vulnerabilities and makes decisions about them, when they should be fixed by priority. And we use it as a first pass triage, a bit like in a kind of medical context. There's always a first pass triage done before you get into the more details and a second pass. And it's a first pass triage for CVEs, and the things like the asset impact, the reachability, the remediation, all of that comes in as a second pass. All right, all those things are important. We talked about asset inventory earlier on. All these things are important to the business and runtime context for understanding the overall risk. That's kind of the end determination. But when you're playing, when you don't have enough hammers to do the whack-a-mole, you want to do a first pass triage to decide, well, okay, which ones do we go after? So the first pass automated triage was we weren't using CVSS scores, even though most of the tools in our DevSecOps pipeline report them. We don't use them. We use the CVSS base score parameters and other input data. This flow was based on a flow chart, and one of the things was that exploitation was a key decision node in the flow chart, and that's what SysACEV recommends. But many practitioners don't use the whole exploitability aspect when they're prioritizing. And the output numbers are this basically were an SLA. It wasn't a high severity. It's a do I need to fix it now or later or whatever? So that was kind of what we had. In addition, then, Frank, you would have mentioned about silos. And, we had a mature DevSecOps pipeline with several tools across the stages. But we wanted to bring the tools and the teams and the data together to inform risk. And that's an important aspect as well. Risk doesn't exist in isolation. And there's different tools and teams involved in detecting and remediating risk across the pipeline. So we wanted to bring all that together. And in trying to come up with a solution, we looked around and about what was out there, and we see, newer things like SysACEV. Ooh, what's that? How can we use it? EPSS that Jay will talk about, and various other data sources. And we wanted to know, okay, we have internal data. We have about exploitability, we have our tool data, and then we have extra. How do we combine all that into something that gives us that first pass triage risk so we can whack the right moles? And some of the things we wanted out of that. So we want to combine all these available data sources to inform risk beyond the CVSS score. And as part of a B-Sides presentation earlier in the year, I presented this risk taxonomy, trying to put all these elements together to give a user guide or orientation to what they do and how to use them. We wanted to share the data and the risk-based prioritization across the tools and the teams within our company. So we standardize on that. We wanted to understand and validate whatever solution we come up with. And this is important. Any tool I use, whether it's for risk prioritization or for scanning source code, I will always benchmark it and make sure I understand and validate it. As a product security engineer, it's on me to ensure that I'm asking developers to fix the right things. I talked about my point of existence is to optimize the flow of software versus security risk. So it's on me to understand these tools. So we needed something that was understandable, not just by the techies, but by the executives. If something is ranked whatever, 0 or high, what does that look like? It needs to be immediately understandable to both the techies and non-techies. So then, given all of that, where we were coming from and what we had and what we wanted, we landed on SSVC. And the key part about SSVC, it's decision trees. Okay. The SSVC was originally developed by the smart folks at CMU, SCI, and it's now being run by some of the same smart folks within CISA. And it's a way to, given different input data sources around about exploitation and automatability and technical impact, to rank vulnerabilities and in our case, CVE. So pretty much what we had all of the goodness of the SSVC decision trees, but it wasn't a decision tree, it was a flowchart. Mm-hmm. And I really, really liked that with a decision tree, one, it's immediately understandable. They're super understandable versus a complex flowchart. And two, you can validate them. You can, get code to generate decision trees or validate, does your decision tree make sense? So you can validate them automatically as well. So yeah, it wasn't a big step for us to go from our flowcharts to our decision trees. And yeah, that's really it. And, at the end of the day, people need to understand of all the vulnerabilities, which ones are the most important, which ones do we need to fix first, and why. The why bit is important, and understand that this actually makes sense. It isn't some black box spitting out a number, and you have to blindly trust it. As I said, given my point of existence, I struggle with that. So that's kind of the journey to decision trees and SSVC for first pass triage of vulnerabilities. So we can whack the moles that we need to whack.
And focus on the critical that are actually critical, because not all the critical are critical.
Indeed, absolutely, yes. Focus on the real criticals. Would the real criticals please stand up? So we can whack them.
As you mentioned, you mentioned 2 or 3 data sources, because not all the data sources can add value and sometimes can add noise, and some others are interchangeable. And we've seen that with the research data that we did. Some others are more trustworthy. If you scrape GitHub, you might find 9,998 potential POC, but of that number, just 400 are actually have high exploitation and verified exploit. And I really like your approach on SSVC, that is getting a little bit more granular and taking the various data sources to actually go in that decision tree and making it as a framework base, so that you can insert some of these data sources that you consider trustworthy.
Yeah, and it turns out, if you look at the data sources that are the best indicators for exploitation, and if you kind of rank them like that, if you start off with, say, internal data, if there's something shows up in your bug bounty or incident response, the numbers there are, let's say, an order of magnitude is in 1. It could be 1 to 10 in terms of vulnerabilities. Then you have things like SysAkev, actively exploited, but not in your organization, but in the wild population, 1,000. Then you get into like EPSS and certain thresholds, the numbers become slightly bigger depending on your threshold, but it doesn't suddenly jump to 200,000. It's a more manageable figure. And then you have things like active exploitation. Is the CVE in nucleus or Metasploit, 2K, 3K population? So the populations, interestingly, gradually increase, in terms of if you walk down the likelihood of exploit. Then you get into exploit available, and then the populations then kind of explode. They're less useful, and there's more of them as indicators of exploitation, when CISA says use the indicator of exploitation as your, for your risk management.
Brilliant. And those are all, I like the fact that you end up going to a matrix that is both understandable as priority 1, 2, and 3, as a single number that can be made a decision on, and it drives away from pure SLA. That is, I think, an approach that I like originally, but it very quickly showed the weakness in terms of approach because it's flat and it doesn't have all that contextual aspect that you mentioned. But on that subject, I wanted to involve a little bit more Marius, and what is his opinion about the matrix from his perspective that really matters when talking about vulnerability risk and all these aspects. What's your thoughts?
I think,
Marius?
it obviously depends where your vulnerability program sits, but, the first and I guess the foremost and most important metrics that you start with, as John mentioned. So obviously asset register, asset criticality. So obviously that allows you to determine and gauge risk, because obviously, crown jewels obviously will have a different risk than someone's, than receptionist laptop somewhere where it's, does not have access to critical data. So that's an important start. Then we go into software list as well. So, who owns particular parts of the software, what kind of enterprise software do we use? So, you start with 2 registers, and then we can start iterating into and translating that into risk language. So, I guess, as we talk about, exploitability and all of that, all comes down to the risk. So I normally like to split it out so you can start trends between business units. So which business unit is carrying more risk than another one. And I think, metrics is important. But as we are changing and we are rapidly moving at this speed and agility nowadays, we can't keep whacking them all. So I normally now change a bit the perspective and how we do things. So obviously it starts with a top-down approach and support of the vulnerability management program to give you authority to actually change culture within organization, because normally the thing is culture is not something that you can implement overnight. Anyone who started doing DevSecOps know it takes 12 to 18 months to get it anywhere near where you want it to be. But what I like is, and what I talked about, business units and trends between the risk, I like to see trends in those risks, because to me, if one of the business units are trending up, yes, we can do whack-a-mole based on risk prioritization and solve vulnerabilities. But obviously, if there is a trending up vulnerabilities, something is broken. So we go to root cause and analyze whether there is broken business processes, whether there is patching that doesn't work. And hopefully, sometimes to get it off the ground, it's much harder and it takes much more work. But I feel that over the long term yields much more benefits if we can, fix the broken processes. How do developers code, and how can we improve their coding practices instead of, just fixing vulnerabilities and creating tickets for them to fix them?
I do agree, and I like that approach on historical trends and also seeing the thing that matters for 2 reasons, because you can give business unit the ability to operate at a specific risk level versus another risk level. So sometimes risk-reward opportunity, you might want to release a bunch of features because you might go out of business tomorrow if you don't release those things. And hence vulnerability and even the critical risk are actually not the most critical things on your table. And being able to adjust your approach on a risk-based perspective is really powerful. So I really like that approach.
And I think it's very important to understand the business context, because your business context will, dictate how you solve risk. Because if you look at, for example, any young company who trying to grab a large market share, they might have a much larger risk appetite, because obviously they need to grow and operationalize their product and grab as much of the market share. When you reach a certain level of maturity, you'll bring the risk appetite down.
I do agree. And in terms of patterns and trending, have you find any behavior also understanding and making the business unit compete as a driver to actually drive down risk or drive down vulnerability? Is there a psychological aspect in making team or business unit compete with each other?
Yeah, and that's the thing. It depends how, I guess there's a couple of angles you can do. You can gamify a lot of it and create a sort of healthy competition, but it's a very fine line between competition and obviously becoming a toxic. But I guess the important part of it is create an understanding, create a relatable training and structure of understanding why we need, why there's specific risks that we have, why do we need to solve these specific risks, and what's the impact. And I feel that's where normally is the disconnect between, especially if we talk with development teams, sometimes we just tell them, go and fix this vulnerability. But unless they are given a context and understanding of why do they need to fix that vulnerability, the chances are it creates a learning curve where you might not see that vulnerability in the future, instead of, just whacking a ticket and say, please solve it.
Most of the time, it's not just one vulnerability, but it's the
Well,
2,000,
yeah, exactly.
20,000 vulnerabilities. It's like, can you please fix this list?
Yeah.
And randomly choose.
Yeah,
But
and I
on
think
that
it's-
subject, sorry.
No, I just wanted to add, and on that thing, I think as well, normally when you go into and expand into various departments, you get a pushback saying, oh, security is not a problem. But it's about how I always try now to relate security with quality. So security is part of the quality properties. So if you want to build a quality code, security has to be built in. Because when I always say to people, when you left the house this morning, did someone lock the door for you? No, you did it yourself. So security is part of your responsibilities in your area.
I like that analogy.
I want to jump into there real quick, because I think going back to what I was talking about originally, you're asking what is application security. I think what Marius just saying sort of hits it. One of the things we've seen over the last few years is application security it used to be a part of the security team, right? Like those dudes in the back who sort of knew what coding was, but they're security people. And we're now seeing that development teams are pushing the budget for application security. So there are a lot of development teams out there are actually embracing that they need to do this AppSec thing, but at the same time, as they embrace it, they want to do it in a way which makes sense to them. So I think that's as we're picking these metrics for what they are, that might be something to also keep in mind. It's like, who's consuming that metric? Is it Marius? Is his like, his directors, or is it like a manager, or like, is it the dude who's actually doing the code?
Yeah.
I like that. And I think it's changing, and it depends on the maturity curve of the organization and also the ownership. And back on the first point, I think we have organizations that consider AppSec separately from CloudSec and infrastructure security. And then you have the more modern organization that look at the full, you build it, you own it, with SRE and observability, where you have full control of your application security stack all the way down to the code and the patching and the infrastructure. So the metric that matters to one organization, I found very painfully, don't matters to other organization, and the threshold that matters for one organization and the methodology don't matter for others. But back on the vulnerability overload, I wanted to introduce Jay and the work that they've done. They've been fascinating work that they've done on EPSS. And I want to touch on the angle on EPSS and application security, because I think it's not a subject that we talked enough, and when it works and when it doesn't. But before diving in, what is EPSS, Jay?
So EPSS is the exploit prediction scoring system, and it basically was born out of the concept that what was it, the Lord Kelvin quote about if you can't manage what you can't measure, kind of a thing. And basically you don't learn unless you have feedback. If you think about trying to hit a golf ball, if you always hit a golf ball and never looked where it went, you probably wouldn't improve much, right? Same thing with vulnerability management and basically anything, that if you want to do better, you have to look at what's actually being exploited and or compromised, and the impact and all the other stuff, because a lot of the earlier comments were absolutely right. It just comes down to risk. And one element of that I thought was relatively easy to measure in vulnerability management was that exploitation, that we can actually go out and gather evidence of exploitation. And I can go into great detail about how how we define that and go after it and capture that data, because that's a huge part of this. But we basically get that evidence of exploitation, and then we try to model what it takes to predict that moving forward. And there's all sorts of interesting tricks and things that we can do to talk about how the past can or does or does not inform the future, and we can measure that. And so that's largely what EPSS is. We gather all this evidence of exploitation activity. We've got a good list of data partners that we're trying to grow, and we use that data then to predict future exploitation activity. And so every day for all of the published CVEs, we publish a score that is the probability that that CVE will be exploited one or more days out of the next 30 days. And we've got a lot of material published on this. We're just at our third paper, peer-reviewed academic paper, and a lot of stuff on the website, and some of it we have to update, but it's all out there. We've got a lot of stuff out there on it. And so that's what EPSS is. It's all about CVEs and the probability of exploitation.
Brilliant. And there is an interesting angle in here, because library have CVE and library have a version, while code is a little bit more harder to measure because it's not static like a CVE. It's not a timestamp version. And I think what I've seen at scale is EPSS has a fantastic effect where you can actually measure something that is fixing a specific version, while in code is actually more challenging because it depends a lot on the context. And you've done a lot of work on this. Can you tell us a little bit more about this very interesting aspect?
The difference between like CVEs and what those represent, and then you have CVEs in the open source libraries, and then you've got vulnerabilities in custom code. And these are, it's a fascinating area to study. First off, it's just super fun. But the system, I think, of exploitation, when something gets a CVE, there's so many things that happen, right? Information gets published. We typically have something that we can start to log, evidence of exploitation for. Without that CVE, it becomes super hard to correlate, someone has this vulnerability, and how do you write a signature to detect it? And what do you call it at that point? And how do you bring different data sources together? It becomes much more problematic without any sort of common nomenclature. And then also, but when these things get published into a CVE, I think that maybe the attackers become more aware, that they start to realize, hey, this is out there. And when you have a custom piece of software that may not be widely distributed and it's only in your one location, that may not have the same exploitation landscape. But when you start talking about open source code, where it is widely distributed, and it does become more like an infrastructure type of thing, like a firewall or a router or something, or desktop, it starts to become more like that CVE publication, public distribution thing. And so there's a lot of nuances here, but it's definitely a fascinating area to study.
No, I do agree, and I see that. One thing that I'm curious about, though, the more we're going to rely on EPSS, would an attacker start looking at the non-EPSS data, so the low exploitability score, to actually sidetrack if everybody's using EPSS or everybody's using a score to use the negative score? So when things get implemented at scale, then we have a big spot and sore spot.
Yeah. So to answer your first question about, are the attackers going to shift and start using EPSS for it? And I hope so. I mean, like, anything we can do that forces the attackers to shift has got to be a good thing. But also, I mean, that sort of goes to like why we need to update this stuff. This isn't like we aren't going to build a model and be like, hey, we're done, we got it, it'll be good for the next 20 years. It won't be, like we're trying to retrain these every 6 to 12 months. And during those months, we're measuring how is it still performing? How are we looking at, 30 days ago, we said these probabilities, how did it perform according to the data we've collected? And so, but you have to keep updating. So if the attackers are going to shift, and they do, and they will, we have to keep updating our knowledge and keep updating what we expect them to do moving forward, and measuring that performance going forward.
No, that's brilliant. And I think you publish on the website several examples, and I talked a lot, several examples where EPSS catch up with the data source that you can see as well as example where EPSS catch up very quickly, like Log4j, I think was the more evident one where specific data source cached it or scored it a little bit faster than EPSS scored it, and then kind of converging. What are your thoughts on that subject? If somebody has to use EPSS, how to optimally use EPSS?
Yeah, so big picture first, it does come down to risk, and EPSS is only the exploitation, right? And so it is not an entire risk picture. You want to talk about, okay, if exploitation activity occurs, first, is this even in my environment? If it is, do I have any compensated controls? How am I going to resist? How am I going to detect? All of those things, and then the asset criticality and what's on the asset and what's going to happen if it is compromised, all of that stuff. And so EPSS is one part of that entire decision. And then the other thing, going back to sort of the timing, the first thing you should do is always act on intelligence first. Like if you know something is actively being exploited, don't check EPSS, because EPSS is a probability. It's sort of like if I flip a coin before I flip it and I say, what is the chance of heads? And you're going to say 50%. And then I flip it and I look at it and I said, do you want to change your opinion because you're wrong? Like, no, you don't have any other new information. But then if we show you and it's either is or isn't, you want to act on that information, right? If you know the answer, don't go looking at an estimate of the answer, right? So if something is being exploited, go after that. Like Log4j, for example, we did a write-up on the website, and I think in the opening paragraph, I said, if you're around and working that weekend, December 10th of 2021 or whatever it was, and you need to check a scoring system for this vulnerability, you're probably doing your job wrong, right? I mean, like the internet was on fire for it. And so like to use that as a poster child to say how good or bad EPSS was, it's sort of irrelevant at that point. But EPSS is 100% data driven. And so it's going to react to the data that it can get its hands on. It doesn't, interpret the various connotation that they're putting out on social media or anything like that. It may look for like volume of posts about something. And so there's some nuance there, but it does look for other things. Like one of the biggest variables that blew my mind was the number of references in a published CVE is a huge predictor. Just the number of URLs in a CVE is a very large predictor. And I think Log4j is over a few hundred at this point in that CVE. And so the average CVE in like the last few years, like 2 or 3. So when you see something with over 300, it's kind of a good indicator that there's something going on there, right? And so the model has sort of figured that out. And then there's other things like, do we see a published exploit, all of that stuff. So if something is published and it doesn't have any exploit code out there, it has 2 references in the CVE, it's got this, it's got that, it's going to be scored low, right? It's looking at the environment, the model is looking at the data it's able to collect, and it's going to score low or towards the bottom or something, right? But, sometimes if it's Microsoft and it's, this particular attribute and this type of vulnerability, it may jump up without some of the huge red flags. And so, I mean, that's basically what it is. Like it's going to react to the data at hand. And generally it does pretty good, but it will be wrong at times, like absolutely. And so if you have other information, use that first. If you don't have information, like if you don't know if it's being exploited, that's where EPSS is going to come into play. It's going to help you, with the beyond the few hundred or a few thousand that you may have evidence of exploitation for, how do you look at the rest of them? And that's what that's going to be good for.
Thank you so much. And I think it's risk reward opportunity. If you are a specific nation state they're going to be highly targeted at day 0 of a ground zero attack, or if you're a particular software provider that has a chain of very critical hospital, or if you're nation state or if you're critical national infrastructure, your risk profile is going to be entirely different, and hence the time to react will be entirely different. While 98% of other folks out there, they just need to be a little bit better than their neighbor. And that's where EPSS, I love EPSS because of that.
Yeah. And to that point, one of the pushback that we often get with EPSS is that we don't offer categories. We don't say this is a critical, this is a high, anything like that. We've got a score between 0 and 1. And the reason is, I think someone said it before, if you're a small organization, you may have a larger risk appetite. You may be more tolerant of taking more risk on, and your threshold for what to fix might be completely different than, say, a large mature financial institution may consider a whole different threshold as being critical, and we got to fix it this month or this in the next 2 days. And those thresholds are going to vary. So for us, from a central organization, to say these are critical and these are high, I think that's a terrible thing to do as a central organization. But yeah.
And I praise your effort on resisting on a top 10 score.
Yeah.
or a scale of 4 aspect of
Mhm.
marketing, because I like the fact that will stimulate the industry to go to a more risk-based approach and probabilistic approach, and consider other aspect that is like critical
Yeah.
element and not all of it. And you might want to just use EPSS to a specific bucketing system, but that's entirely up to your risk appetite.
Yeah.
If
Yeah.
I
And
could
one
add
of
real
our
quick,
go ahead.
I was going to say, if I could add real quick, I wanted to expand on one of the things that Jay, you had mentioned, mentioning log4j, or just like these are probabilities. In the spirit of what can AppSec do, AppSec can also help with the idea of run a tabletop exercise before the next 0 day or the scary log4j or whatever. Take a vuln, say, what if the EPSS score is the magic 100%? Let's just roll that.
Mhm.
And that type of tabletop exercise can help you say, well, do we have an asset inventory? Even mature organizations probably don't have one, but it can start to help you say, well, we have a pretty good one in the cloud because AWS knows how to bill us for our resources, so we can find those resources. But maybe we have these other gaps, as well as it's going to get that sense of, can we fix this fast? Meaning, is our CI/CD pipeline, do we have tests that don't have like a break glass capability to them? So we actually have to wait 6 hours to push through a release. And all these can be done in the much lower stress environments when you're not over that weekend of dealing with Log4j. So that's one of those things that AppSec, I think, can help with, and spend time on this more strategic, more helpful to the organization than just go fix this.
Yeah, and think
Just
about
remove it.
the scramble just in Log4j about finding where it is. Exactly to your point, like the asset inventory and all that. So sorry, Chris, go ahead.
No worries. Yeah, I was going to plus one on what Mike said, is in the asset inventory is important, and the software inventory as well, is, what software, what libraries have you got? The other interesting thing that where AppSec can help, but nobody uses, is understanding root causes for things, is in gathering all your data, doing the data analysis, coming up with the root causes. Is your software 10 years old, whatever open source dependencies, or whatever the thing is, coming up with the root causes for all your software and data in your AppSec pipeline is a fairly simple thing to do with the exploratory data analysis tools, but nobody does it. And it can be done at your leisure before the next 0 day critical thing drops.
Maybe I'm gonna be facetious here. I'm gonna be controversial. Shall we stop calling it threat modeling exercise and call it business continuity exercise? Because that's what Log4j was. We were on the brink of being afraid to be crippled, or the Zealous vulnerability, and depending who you are, which side of that data breach you were, is still business continuity. As long as we call it security or AppSec thing, it's going to be relegated in the realm of, yeah, that's a security thing. As soon as we call it, well, let's do one business assessment of like, do we have the asset information? If we lose this asset, what is the business impact of that? Do we know that our third supplier or our software supplier is going to be compromised with this? What is the impact from a business perspective on our critical survivability? I found that calling it with different name can bring maybe different people on the table.
Yeah, and sorry, I'm just gonna add, Francesco. I think it's the way I think the whole industry is trending as well. Because we've been talking in the latest San CISO networking event as well. So 2010s were all kind of us trying to reduce the likelihood of risk, which always has been done sort of at the perimeter and edge security, whereas 2020s feels like it's inevitable that something's going to happen. So how we can reduce the impact, and we shifted from reducing the likelihood to reducing the impact. And actually, should something happen, how do we still maintain business operations and actually still take money? So I think that's where sort of our industry is moving now.
I hear definitely the aspect in the CIA triad, availability as the primary aspect of that business continuity. But in the spirit of what you're going for, BCP sounds great. And then maybe also throw in like privacy aspect, because a lot of organizations now have a chief privacy officer or fall under CCPA, GDPR. And there's a difference between Log4j did that just impact continuity, impact availability, or was that on a system that has customer data, privacy? So I'd be happy to move on from just calling everything threat modeling and aligning that language with obviously with the people that are involved, because a lot of like BCP and privacy typically don't have very strong AppSec presences.
Brilliant. So let's move on from application security, threat modeling into business continuity. And how can we use the data-driven model to actually assess, hold on, our asset inventory that we've been fighting for years, or our supply chain that is, I don't think is a new thing. We've been fighting this since Struts, and we don't seem to learn the lesson of there is a particular library and a particular piece of software that might impact across the board. But what I've seen, and I want to hear the opinion on the panel, is the likelihood and the perspective and the amount of time those library got attacked made all the business shift in terms of likelihood of those things to happen. Struts happened one point in time, and then there was quiet up until OpenSSL, Heartbleed, and few others. Well, right now we're seeing an exploit of a software library, open source library, on a very much more consistent basis. What's your opinion? Let's start with Mike.
Ooh, I get to talk again. I think Struts is interesting. I think there was an article, somebody wrote a blog post this summer about Equifax, pointing out that Equifax, for the most part, fixed their Struts, what they knew of, within 48 hours. What they got caught out on was their asset inventory didn't cover this legacy system. And so, and I think if I remember correctly, the legacy system wasn't even exploited until roughly 30 days after the exploit, the vulnerability had been announced. So I guess I want to pull this back. My answer will come back around to asset inventory, which John started us off with, and the time to response, and the metrics around time, meaning perhaps time that you can identify, are you exposed to this? The time it takes to fix, but it would hesitate to gamify that. But also, and maybe a little bit of EPSS would help out this, but the time you're taking away from your developers, meaning you're telling them about all these low risk vulnerabilities, or you're just telling them fix this, fix this, fix this, fix this, in the sense of so many alerts that's just a distraction. So I guess I'll throw in my time as my dimension, being a Doctor Who fan.
Brilliant. Chris, what's your opinion on it?
Yeah, so long time ago, I won't say which company I was working in, I was aware of the risk associated with software and open source software. And just because we're talking about open source software, that just to highlight, that doesn't mean all the vulnerabilities in open source. It just means that 80% of the software in our apps is open source, and we're talking about that here. There's all the vulnerabilities in the software we write, which is separate, right? So just to clarify that. But yeah, so a long time ago, within a company, I had put together this software supply chain risk management value stream, which was an adjunct to our software assurance for the software we write, and trying to explain, look, across our build pipeline, the open source software that we intake, it's a risk, and here's why, and software supply chain and all that. And it was like, what's all that about? And then SolarWinds came along. and then life as we knew it changed, and everyone knew what that was about. And so it's kind of funny to see how the perspective changed. And it's the gift that keeps on giving. We have the Spring shells, Log4j's and shells, and they're all all these things. And now software supply chain risk management it's become a thing, and everyone knows what it is. No explanation required, and that's a good thing. It exists. We're now, interestingly, I think, at the stage where there's a lot of standards popping up around it, and there's many. I've in a sort of separate recent effort I was involved in with a professor. working with industry, let's say companies, and developing a proactive software supply chain risk management standard, so people could look at it without having to read the 20 different standards in supply chain and figure out, well, what do I need to do? What's everyone else doing? And what do I need to do? So that's all concept of software supply chain. It's maturing as sort of, on the back of SolarWinds, etc. But we're not there yet. Like, and you hear about SBOMs. We should all have SBOMs, but in reality, nobody has working SBOMs, I think, and that's a strong statement, but they're not at the point where everybody's using them and they're useful. My colleague DJ has a whole podcast with the thought leaders on that. Is called thebomb.show, and so SBOMs will come as well as a follow-on. So it's an area that's maturing, and there's lots more to happen in this space.
Brilliant. And I think with Steve Spring that we discuss about even the evolution of SBOM to PBOM and software bill of material that is extending away from just pure libraries to actually asset management. It seems to joke and go back to asset management. But on that software asset management, John, what's your opinion? Are we gonna get to that point, or are we gonna just circle on it?
I think software asset management, we should have a chance. And the reason I'm going down this path is more and more of what we're doing is automated. Less and less of what we have is a developer has a Mercury repo like underneath the desk or something like that, right? We're using, most of us are really shifting towards GitHub Actions. I don't know, pick the Amazon or the Azure version of it, but some sort of centralized code base. SBOMs, I think, are, and we covered some on ASW earlier this year. SBOMs themselves are fairly easy to generate, lots of ways to do it. The question is, what do you do with them? Now you've got this other thing to track in your inventory. The tools they're improving compared to where they were a year ago, but still, this is definitely one of the situations where the thing was made before the things were made to do something with that thing. So inventory is improving. I think the one interesting thing, from the earlier comment about internal versus open source code, the internal code is just where when you create the vulnerabilities, you keep them to yourself, versus with open source, you share the vulnerabilities with everyone else. So you still have to do something with them, right? You have to track them. You have to understand where they are. They're probably going to be harder to find since you don't have signatures or sort of more common methods of tracking those things down. But yeah, I think it's a lot of this also comes down to that maturity model. Like, where is someone, like, sort of both how big is an organization? How many of these cats are you trying to herd? But then also, how sophisticated are you in your herding, right? I don't know what my analogies today. Do you have a bunch of sheep hounds that are like really well trained for your whistling? Or is it like, you're just sort of like throwing rocks and hoping that the sheep go in the right direction? So there's a lot of, wherever you are on that maturity model is going to come down to which one of these tools you're going to be using and how do you use it? I mean, okay, imagine if I gift you like a 5-person shop some $150,000 asset inventory, software inventory system that would take 2 or 3 guys full time to run, plus the training, plus everything else. It's useless to them, right? So it has to. It's not just the sophistication of the metrics, the tools. How do you find these things? But also has to be matched with what are the capabilities of that organization. Where are they on that maturity curve?
And I like the maturity curve, but we have a few minutes, so I want to just manage to touch Jay and Marius. Jay, what's your opinion on, are we getting more and more mature or less mature?
I would love it if we can look back in 5 years and look at the time now and sort of laugh at how archaic we are or something like that. Like, we advanced so much that this looks ridiculous. That would be awesome. But I want to touch on this automation thing that John was talking about. And I think that's so critical. I think it is absolutely critical. It's more from like a remediation standpoint. So if you're building libraries, open source code, anything like that, they'll have some reuse. The ability for people to put that in place, put a new version in place without the hassle is really, really critical. And so, like, as we're studying remediation times, if anybody remembers Microsoft from like 2000, they were terrible at security, just absolutely terrible and pretty widespread. And they would put out patches that would bring down systems. And one of the biggest things they did was made those patches more reliable. And then they started Patch Tuesday and made the timing more reliable. And now they are one of the fastest platforms to get remediated when vulnerabilities are found and CVs are issued and getting patches out there. They are one of the most quickest remediation things to happen on networks. Now Google is catching up with Chrome being auto-fixed, things like that. In open source, we need to be able to give people that trust that when something needs to be updated, that it can be updated. If it's going to cause hassle, one of the worst things, actually, slowest to be remediated is Java. It is by far one of the slowest things in any network to get updated and remediated, because I think anybody who worked with it knows that pain. And so I think that's one of the areas that, from a remediation and robustness of resilience of code, we need to work on that remediation and fix strategy and make that a lot more painless.
No, I like the example, because I think regression testing, the scare of something to be broken, and the ramification of upgrading and bumping up a library of, God forbid, a source control or a Java virtual machine from one version to the other that's going to break completely the method, or even Spring Boot and the rest of the methods are still terrifying because of the amount of regression testing that people want to do. But we're getting better where risk reward is actually lower and lower and lower, and reachability versus just bumping up a library is getting less rewarding on actually decompiling that library and identifying where is the vulnerability versus just pump up the library. Marius, what's your opinion on it?
I think we are moving in the right direction. I think especially because we are working now in, everything's becoming interconnected. Most of the organizations moving into the cloud. So I think the way we can negate some of the work that we do in some of the manual work is we now can start scaling our governance policies in cloud at scale. So as long as we set our correct governance structure and strategy, you can fix some of the stuff just by policies of enforcing, repeatable processes time and time again of how and what you fix, and then whatever you need to test. And obviously you can, again, create an automated test where you just have a person overlooking instead of, actually person doing those tests. So I think we're on the right track. We just obviously, there's still some time to go until we get there. But I think, as technology evolves, our thinking evolves, and how we address that, it's going to be, I think, hopefully we're going to get there soon.
Brilliant. And we just time. So I want to leave everyone with the hope that in 5 years, as Jay said, we're going to look at this podcast and this panel, and we see we advanced so much that now all the asset management are done, risk assessed. We have real-time information about the asset, the exploitability, and attacker don't have a chance anymore to breach. But unfortunately, I'm a pessimist and an optimist at the same time. So I think we're going to face a different kind of challenges, and we're all going to have a job tomorrow as we have it today, defending our organization. But hopefully it's going to be a little bit less stressful and a bit more interesting than just chasing up a library and a patch. Everyone, thank you very much for the time that you came today. It's been a brilliant panel. I know that we're at the time. If you want to leave with the last thoughts, I'm going to just do a very quick last thoughts on the subject. I'm going to again start with Mike.
You don't have to fix all the vulns. Have a different conversation with your developers about anything other than just fixing a bunch of vulns. Talk about design, something like that.
Brilliant. Jay.
I think the biggest thing is feedback. Whatever you're doing, try to do it in a way that you can look at the feedback from your decisions and actions, including design and all of that stuff.
Brilliant. Chris?
I think understand your data. That's really understand what you have and the data from your tools and put it together holistically. Disclaimer, no live moles were whacked in the making of this presentation.
I love that. John?
That's cute. I'm going to say, think about your budget, right? So it doesn't matter if you have 10 million things out there to fix or 5, but it comes down to what is that budget, both monetary plus your resources plus your skill set. And then based off that, you have to figure out what you're going to do with it.
Brilliant. Marius.
I would say take your organization on the culture journey and how we can collaborate between the teams and get them together. It's not operations versus, security or versus development. It's how we work together and get that problem solved.
Fantastic. And I'm going to leave everyone with the last thought, that is, let's stop calling it vulnerability management, application security, and let's call it business continuity and survivability. Everyone, thank you so much. It was a beautiful panel, and stay safe out there. See ya.
Thank you.
Thanks, Frank.
Bye-bye.
Thank you.